Welcome back, and in this lecture we want to talk about the processor speed, how fast the PIC runs at. This is also called the oscillator frequency. Now, you've heard me say that the chip is running very fast at 1 megahertz, and in this sort of sample code I actually configured the USART module for 9600 bits per second on a chip running at 1 megahertz. This stands for the 1 megahertz speed over a computer chip. Well, it turns out that you can operate this PIC on a number of different speeds. There's a table in the manual taken from the data sheet for this PIC, and in here it turns out that we could operate this anywhere from 31 kilohertz up to 8 megahertz. So we actually have 8 possible speeds. This little note here is simply saying that the default speed is 1 megahertz. It's even better than that, though. There's a turbo feature that you can also use, which for the 2 upper speeds can increase the speed by a factor of 4. So besides 31 kilohertz to 8 megahertz, you can also get 16 megahertz and 32 megahertz. It's done in a library called os.c.h. And in os.c.h, let me call up the code here and make it larger. Here's the code. So what it's doing, it's taking the bits listed here. So the default is 100. I come back to here. So this is 100. It set those bits to that, right? And down here it says turbo, currently disabled, right? Set to 1 at 4 and 8 megahertz to get 16 or 32 megahertz. So that's all you have to do. You just have to set these 3 numbers and possibly this number to get any other sets of speeds. So let's do that. Let's get 2 megahertz because that was one of the choices. So Control C, come down here, Control V, keep the naming consistent, 2 megahertz. We go back and see that 2 megahertz is 101. So all I have to do is change this here, 101. So now if I use this, the chip will operate at 2 megahertz. I've created this function, but I should go back and in the header file, right, also have the prototype for that function. So that's all I had to do. That's all I have to do. I'm going to make you set up all 10 possible speeds, right? So if I wanted this to work at 2 megahertz, set underscore OSC to capital M, capital H, Z, like that. Set the oscillator to 2 megahertz. Get rid of that. And if I wanted this to work correctly, I just set it to 2. So I will have you set up all these different frequencies. You might ask, so what? Well, sometimes you want your chip to operate really fast, and at other times you want it to operate very slow, because when it's operating slowly, it doesn't consume as much energy. So if you were to put this, say, out in the wild, you don't want to come back and change the batteries all the time. So you would operate it as slowly as you need it to. And so this is a nice flexibility of this chip. There's a couple of things that I have to warn you about. First of all is this table right here, also from the book. And this line in here is telling you that there's a maximum operating frequency that you have that depends on the operating voltage that you're using. I do the calculation down here. We're operating at 3.3 volts. Okay? When I do the calculation, the maximum I can safely go to for reliable operation is 25 megahertz. So the actual top speed that I can use would be the 16, but not the 32 megahertz. So we really only have 9 possibilities. One thing to remember again, every time you change the speed, right, if you're going to be using putty, you need to change this guy so that you can speak to putty properly. Now, there's one other thing I want to tell you about, because you're going to create these functions. We also, in configuration bits, have this little comment here, right? And it says, the output frequency can be checked by looking at pin 10, which is array 6. So in the class, when you've got this set up, we'll choose different frequencies. And on the scope, you'll see that if we're running at 1 million hertz, then the oscilloscope will measure 250,000 hertz. And if we were running at 4 megahertz, it would read a signal of 1 megahertz out of array 6. We'll be testing that. Okay. Now, I also want to warn you a little bit more about this configure USART function. Here's the rate at which we want to speak to putty, a very standard 9600 bits per second, where we're operating at 2 megahertz. If you go back into configure USART, and I'm going to do that right now, it uses a quantity SPBRG and this function to generate that speed. This guy is an integer. It only runs from 0 to 65,535. To get the correct value of this number and the baud rate that you want, there's a formula in here. Okay? And we're going to look at that formula, and there's a few things I want to talk to you about. So here we are, back at this page. So here's the formula from config USART written nicely. So this constant that the function uses to set the baud rate speed is the oscillator frequency divided by 4 divided by the whatever speed you want. We use 9600. Then it says plus 0.5 minus 1. Well, I'll explain what the 0.5 is for. This guy's an integer, and so whatever this number is, it's probably going to be a decimal number. So if it was like this, will round it up so that when it rounds, it's closer to the value that we need. Here's an example. So here it's 1,000,000 over 4 and divided by 9600. Add 0.5 minus 1. So that 0.5, right, brings it up a little and keeps it a reasonable value. Because it's an integer, it's going to be rounded down to 25. The reverse function, the actual baud rate that we're going to get, is FOSC over this formula. And when I plug in the numbers, I don't actually get 9600 baud. I only get 9615. That's okay. USART communication is actually rather flexible. When we say we want 9600, it doesn't have to be 9600 exactly. There's a bit of slop in the, should I say that? In the protocols for the communication. So as long as you're reasonably close, within a few percent, then you should be able to communicate. Probably you need to be within about 10%. So if you should find in your program, let's get rid of this, in your program that you don't seem to be able to get communication, or it's erratic or strange characters, it's probably because you're asking for 9600, but what you actually get is not close enough. And you may have to choose a different value, and USART allows you to operate at many different values, or you need to change the speed that you're working at. I think that's everything for now, so we'll finish right